Suppose A and n greater than 1, B and n greater than are two boundary sequences. Suppose A and n greater than 1, B and n greater than are two boundary sequence of real numbers. Now which the following is true? Limit supremum n tends to infinity, n plus minus 1 over n into Bn. Limit supremum n plus limit supremum Bn n modulus n tends to infinity, and limit supremum n tends to infinity, n plus minus 1 over n into Bn. Less than equal supremum, less than the limit supremum n tends to infinity, plus limit supremum Bn n tends to infinity. Option 3, limit supremum n tends to infinity, n plus minus 1 over n. This option are there. What is the question? Now to solve this is very UGC CSR net mathematical science question. So how to solve this question? First to solve this question, how to solve this question? Especially option limit supremum n plus a and b and are two boundary sequence. Suppose a minus 1 over n and bn equal to minus 1 over n. The sequence is bounded. How the sequence is bounded? The sequence n is equal to 2 value minus 1 over n. It has a 2 value. When n is even 1, when n is odd minus 1. They have a 2 points minus 1 to plus 1. But every bounded one result we know that every bounded sequence is not convergent. That is, A and B are not convergent sequence. This is not convergent sequence. First, let's one option. First to choose the one option, that is limit supremum n plus minus 1 over n into bn, n tends to infinity, equal to limit supremum n tends to infinity plus limit supremum bn limit supremum bn n tends to infinity modulus. How to consider this? n equal to minus 1 over n and bn. Limit supremum n this maximum value is 1. But how to choose bn? Suppose limit supremum bn has a maximum value. How to choose? This value is not equal. Suppose bn is taken as what? Bn taken as minus 1 to what? Minus 1. So bn is minus 1. Suppose bn is minus 1. Suppose constant. Bn minus 1 over n into bn. That means minus 1 over n into minus 1. That is minus 1 over n plus 1. This term has 2 value. How this? If n is even, suppose n is odd. N is odd, suppose 3 plus 1 4. That's 1. Suppose n is even. So 2. 2 plus 1 3 minus 1. That's 2 value. 1 to minus 1. So how to choose n? Any constant term choose. Limit supremum minus 1 over n into bn. Maximum value. This maximum value is how much? Minus 1 over bn. This maximum value plus 1. And this constant term is choose also. Suppose any constant term choose. So limit supremum n is any constant term 1 and limit supremum bn n tends to infinity. Any terms. Suppose supremum bn constant term. Its modulus is 1. 1 means, that means any constant term you have to choose. Suppose we have to take as 0 constant term. Suppose a over sequence taking as 0. Sequence 0 constant term. 0 sequence means n sequence is 0 constant term. This means 0 0 0 0. This sequence is 0. So limit supremum n tends to infinity is what? Limit supremum n tends to infinity is equal to 0. That means 0 plus implies that 0 plus limit supremum n tends to infinity minus 1 over n bn sequence. That means this is the maximum value. This is the limit supremum n tends to infinity minus 1 over n to bn. That is maximum value is how much? Plus 1. 0 plus 1 1. According to this, limit supremum n tends to infinity constant of 0 plus bn is a maximum value. Maximum value limit supremum bn n tends to infinity. Any maximum value to the very any maximum value, that is 0 plus 1. Limit supremum bn n tends to infinity. Only bn is a maximum value. Suppose constant bn. Suppose bn we have to choose maximum value minus 1 over n. Maximum value plus 1. Not equal. It is never be equal. That means supremum, suppose constant term 1 plus 1 to any value that is not equal to 0. Suppose 1 suppose minus 1 over n bn, suppose the limit supremum n tends to infinity, and that is a supremum, that means any constant term 1. This value, suppose n is sequence is 1 term. Sequence 1, then this is the sequence minus 1 term. 1 minus 1 0 term, and minus 1 of bn. So bn term is 1. Suppose bn sequence is 1. Suppose bn term sequence is 1 taking h. Then minus 1 over n is what? Into 1. The 2 value 1 1. That means this is 1 minus 1. This is 1 minus. Then minus 1 of bn is equal to what? N is constant of bn. Bn is equal to 1. Suppose bn we have taken as 1 minus 1. Suppose we have taken the bn term is what? Suppose n constant term. Suppose n is constant term 1 and bn taking as any constant term, that is minus 1 over n, that is 1. Suppose that is 1 is n is a odd term. Suppose n is 1 negative. Suppose n is 1, n plus 1. Suppose n plus 1, bn is minus 1, n is 1, n is equal to odd terms, and minus 1, that means 3 plus 1, n is odd, 3 plus 1, 4 is even term. Over n is 4, so n is even, this is even term, this minus 1. Then what is the happening? A is a constant term. I will know that every constant term, every constant sequence is bounded. Every constant sequence is bounded, we know that. Result 1, every constant, n is a what? N is also constant sequence. Then bn is how much? Minus 1 over bn is how much? Minus 1 over n to bn. That means when n is odd, that is minus 1. When n is even, plus 1 into minus 1, minus 1. This is the result. I want this, get this. That means 1 plus limit supremum n tends to be 1, and limit minus 1 will be maximum will be minus 1. That means less than which is equal to limit supremum n plus 1. That is limit supremum bn n tends to infinity. Bn, that is bn value what? 1. So 0 is always less than equal to 2. Which is equal? So 0 is equal to 2, not possible. So this is not possible. So option 1 is discard. So option 1 is discard. Then going to next question. Then going to next option. So how to solve this? So limit. Let us assume the option 2. Limit supremum n tends to infinity n plus minus 1 over n into bn less than equal to limit n tends to infinity supremum n plus limit supremum bn n tends to infinity. This is also how to solve. This also satisfy or not satisfy. Suppose any sequence. Suppose n is 1, any constant sequence, and minus 1 of n into bn. Possible. Bn suppose sequence is any constant 1 sequence. Then minus 1 over n into bn is, suppose bn is minus 1, then minus 1. Then minus 1 over n plus 1. This sequence is what? How much? Suppose n is even term. Suppose n is even term. N even term 4 plus 1 5 minus 1. Suppose n is odd term. N is odd term. And 3 plus 1 4. This is plus 1. Limit supremum n plus minus 1 over n. That is any constant term. Constant term sequence. Supremum, that means greatest lower bound. That is 1 plus minus 1 over n into bn sequence. That is 1, which is less than equal to limit supremum n tends to infinity, which is 1 plus limit supremum bn n tends to infinity. Only bn. Only bn means it is a maximum. Suppose minus 1 over n. This is the boundary sequence. Suppose any constant sequence. Suppose bn is minus 1 over maximum 1. Suppose n is 0 sequence. 0 plus 1. 0. Or suppose it is 1 sequence. Suppose this is 1 sequence. So 1 plus 1, limit supremum 1 plus bn is your, how much? Bn is maximum. So maximum, this value is maximum. So minus 1. Suppose minus 1. 1 plus 1. This is suppose minus. Bn is a constant sequence. 1 plus 1 minus 1 0. So 2 is less than or equal to 0. Will not possible. Will not possible. So option 2 is discard. On the option 3. Option 3 is how much? Option 3. Option 3 is limit supremum. Limit supremum n plus minus 1 over n into bn into n tends to infinity less than equal to limit supremum n tends to infinity plus limit supremum bn n tends to infinity modulus plus limit infimum bn n tends to infinity. In this sequence type, very interesting question. In this very interesting question, which other part? Suppose n is any constant term. Yes. Suppose n is any constant term and bn is what? Bn is minus 1. So minus 1 over n into bn minus 1 over n plus 1, that is minus 1 over n plus 1, that is obviously know that is we obviously know that this is minus 1 when n is even, that is 3, 4 plus 1, 5, that is plus 1 when n is odd, term. This function is what? 0 plus, it will limit supreme maximum minus 1 over n into bn. This maximum term is plus 1, 0 plus 1, which is less than or equal to limit supreme n, that is constant term 0 plus limit supreme bn, that is constant term plus 1, and limit infimum bn. Infimum means any constant term. So 0 is any constant term. Bn is how much? So bn is minus 1. Minus 1, that means very constant. Minus 1 is a very constant term. So maximum value. Maximum value is very means minus 1, that is that term. So minus 1 the modulus plus 1. So 1 is less than or equal to 2. This satisfied. 1 is less than 2. This satisfied. Option 3 is satisfied. Now we are going to next option 4. Option 4. We are going option 4. Option 4. Option 4 is limit supremum n plus minus 1 over n into bn. N tends to infinity, may not existence. इसका लिमिट एग्जिस्ट करेगा नहीं करेगा? इसका लिमिट तो जरूर एग्जिस्ट करेगा. कैसे करेगा ना? n equal to minus 1 over n is bounded, so bn is minus 1 over n, it is also bounded, constant is bounded, so may not exist. It is also existence. The bounded existence, so limit is also existence. So option 4 is discard. Very interesting question. You will see going to next question. So we consider function f r square tends to r defined by function r square means r cross r coordinate. R cross r coordinate is xy, and r cross r is xyz coordinate component. Function xy x 1 by 3 y 1 by 3 xy will start with the following. It will prove that a derivative function exists at 0 0 in the same direction. The partial derivative of function fx does not exist at 0 0. F is continuous at 0 0. Function is not differentiable at 0 0. So how to solve this first statement? The derivative of function exists in the same direction. So how to derivative exist in the same direction? Derivative, the function. So limit existence. Derivative exist means the limit existence. The derivative of function, that means the derivative of function. The derivative of function exist means function exist. That means limit exist. That means limit existence. That means, so derivative of limit is limit x tends to 0 function 0 plus h cos theta, 0 plus h sin theta minus f of 0 0 by h, and h tends to 0. Limit the function x y coordinate minus f of 0 0 by h. And how to solve this problem? Limit h tends to 0. Function, this is h cos theta, h sin theta, and the function xy satisfy this equation. H over 1 by theta and cos 1 by 3 theta, and h 1 by 3 sin 1 by 3 theta minus x0 y0 0 by h, that is limit h tends to 0, h over 1 by 3 1 by 3 2 by 3 and cos 1 by 3 theta sin theta by h over 1 minus 1 plus 1 1 plus 1 2 by 3 1 minus 2 by 3, that is 3 minus 2 3 minus 2 by 1 by 3. So limit h tends to 0, cos 1 by 3 theta sin 1 by h over 1 by 3. This limit existence. This limit exists. When हम कैसे कहेंगे इस लिमिट एग्जिस्ट कहते हैं, कहाँ पर लिमिट एग्जिस्ट करेगा? यदि sin theta cos theta value, if this value is 0, then limit exists, otherwise not exist in this value. So 2 sin theta into cos theta by 2 to the 1 by 3 into 1 by 3, 2 sin theta into cos theta by 2. Then in sin 2 theta, to the 1 by 3 attached to 0, that is sin 2 theta tends to 0 when the sin theta is 0, when theta is 0, theta is pi, theta is 2 pi, theta is 3 pi, pi by 2. 2 theta is 0 means sin pi is 0, theta value is pi by 2, 2 pi by 2, 3 pi by 2. Then limit is existence, derivative also existence, so that हम कह सकते हैं derivative of first option, the derivative of the directional derivative of function exists in the same direction. Option 1 is right. Option 1 is right. Going to second option. Second option, the partial derivative of function f(x) doesn't exist or change. On the second, the partial derivative. The partial derivative of function f(x) does not exist at 0 0 point. The partial derivative of function f(x) does not exist at 0 0 point, and function is continuous at 0 0 point. The partial derivative of function f(x) exists means f(x) partial derivative at 0 0 point. The limit h tends to 0. F function h tends to 0 minus function 0 0 by h minus 0 0. The limit h tends to 0. Function is h0. That means x putting x value on h value on x and y value 0. That is 0 minus above 0 0 by h. That is 0. 0, then function fx 0 0 existence. So option 2 is exist. What the function partial derivative existence, or the option is partial derivative of function does not exist. Option 2 is discard. Going to third option. Going to third option. F is not differentiable at 0 0. Function is not differentiable at 0 0. So how to calculate the derivative? To check derivative, to check the function is derivative, function is differentiable. Which formula is applied? Function is differentiable. The which formula is applied? That is limit hk tends to 0 0. Function of hk minus function xy. Suppose function of xy at this coordinate hk or xy minus a into h minus bk by h rho square plus k rho square root over h rho square plus k rho square root over. So limit, according to the limit, this point, limit hx tends to 0, limit hk tends to 0 0. Function hk h to the power 1 by 3 into k to the power 1 by 3 minus function f of xy. At this point, f of 0 0, this point f of 0 0 minus a into 0 minus b into k 0. This point h rho square plus k rho square root over this point, and limit hk tends to 0 0 h over 1 by 3 into k over 1 by 3 0 0 0 by h rho square plus k rho square. Now taking this first and now we consider like this. H is equal to y is equal to like this, y is equal to mx, similarly k equal to my, mh. Putting this value, put this value on this result, putting this value on this result, limit k tends to 0, h to the 1 by 3, k value m to the 1 by 3, h to the 1 by 3 by h rho square plus k rho square m rho square h rho square root over, then limit k tends to 0, h 1 plus 1 2 by 3 m to the 1 by 3 by h 1 plus m root over h is cancelled out, 2 by 3 minus 1. This value does not exist. This value does not exist. Why? This value exist नहीं होगा. क्यों? Is for this m value. For this value of m. So the partial differential equation, the partial derivative of this. So partial derivative of function fx does not exist. Partial derivative fx does not exist. Second option, third, fourth option, f is not differentiable at this point 0 0. So f does not exist. This function is not differentiable. So the fx is not derivative. Does not exist. So function is not differentiable. So partial derivative is not existence. And suppose this function is what? This f does not exist. Function is not differentiable. Why not differentiable? This value is not exist. So limit is not exist. So function is not differentiable. Function is not differentiable at this point 0, 0. Okay. Going to next question. This is very important topics. Let x shall be defined by x equal to x and n greater than 1 sequence. Limit supreme x and n infinity equal 1 और एक्शन goes to 0 1 हमें एम ऐसे एक सीक्वेंस लेंगे जिसमें एक्शन goes to 0 1 आएगा एक सीक्वेंस लेंगे 0 1 0 1 0 1 एक सीक्वेंस लेंगे सपोज एक्शन एक सीक्वेंस लेंगे तो 0 1 आएगा और 0 1 आएगा ऐसे एक सीक्वेंस लेंगे greater than 1 limit action does not exist x and y is a sequence action n greater than 1 limit action n does not exist for action goes to 0 1 x y are uncountable x y are countable x is countable and y is uncountable x is uncountable and y is countable. Which option is correct? This is very part C question of CSS and mathematics question. This is very important. So suppose this question is very interesting about suppose y is equal to xn. Y is equal to xn if the sequence is n greater than 1. Limit x and n not does not exist. That does not means x is not convergent. X is divergent. Divergent means x value कितना value आएगा ना y value है x1, x2, x3, x4, x7. हर एक में two value. It also provides two value. x1 value 0 होगा 1 होगा x2 value 0 होगा और 2 होगा x3 value 0 होगा और 2 होगा मतलब हर एक सीक्वेंस के लिए दो ऑप्शन आ रहा है दो ऑप्शन आ रहा है मीन्स हर एक सीक्वेंस के लिए 0 आ रहा है और 1 होगा 0 और 1 और 2 होगा 0 होगा इधर 1 होगा 0 होगा और 1 होगा 0 होगा और दोनों ऑप्शन टू ऑप्शन आ रहा है कितना सीक्वेंस होगा ऐसे हम वो 1 2 3 एक सेट है सिर्फ दो चॉइस है 0 1 और 1 के लिए दो ऑप्शन 2 के लिए दो ऑप्शन 3 के लिए दो ऑप्शन सही आ रहा है इसलिए कितना आ रहा है 2 ओवर epsilon that is c. Now we don't have any formula that we have the formula that 2x to c 2x equal to c epsilon 2 giant to c is uncountable set that is mean x uncountable set that means x is uncountable y is uncountable set that is y is uncountable set so x is what x is uncountable set so y is some value y is uncountable set so y is countable now to check that x is uncountable set or not how to check that x is the uncountable set or not that is we know that what limit infimum xn less than equal to limit supremum xn or limit infimum xn less than equal to limit supremum xn n tends to infinity और n tends to infinity हम ऐसे कह सकते हैं सपोज xn एक सीक्वेंस लेंगे जो y से बिलोंग कर रहा है एंड जो इसका जो लिमिट लगे y इज इक्वल टू लिमिट xn और सीक्वेंस का जो अपर लिमिट सुप्रीमम एक्शन इज हाउ मच 1 एंड लिमिट इनफिमम तक कितना है लिमिट इनफिमम एक्शन n बिलोंग्स टू इन्फिनिटी that is 0 0 और 1 आ रहा है, that means वो x में वो जो सीक्वेंस है x वो सेटिस्फाई कर रहा है. Then y is subset of x. Y is subset of x. How is it? Now y के जो दो पॉइंट आ रहा है 0 और 1, वो x भी वही पॉइंट आ रहा है 0 और 1, वो लिमिट को सेटिस्फाई भी कर रहा है. इसलिए इस सेट कैसे आ रहा है, x का लिमिट पॉइंट कैसे आ रहा है, तो y का जो लिमिट पॉइंट आ रहा है, जो x का लिमिट पॉइंट है 0 और 1 में आ रहा है, इसी तरह से x का जो लिमिट पॉइंट है वो कैसे आ रहा है 0 1 0 1 0 1 0 1 ऐसे ऐसे आ रहा है. इसका जो लिमिट सुप्रीम आ रहा है 1 आ रहा है, इसका लिमिट इन्फिनिटी आ रहा है 0 आ रहा है. सो y is subset of x. So as that we know that a is a subset of b. So a is uncountable. Subset is uncountable, means set is uncountable. Suppose a is a subset of b. A is subset of b, that means is a subset है, वो तो uncountable हो गया, तो b तो uncountable होगा. A is countable, b is countable. So y is uncountable, so x is uncountable. That is proof. That is proof. So x is uncountable. X is uncountable set. As x is uncountable, that's y is uncountable set. So both y and x are uncountable. So both y and x are uncountable set. Uncountable set. Go to the next question. Very interesting question. We consider series summation n equal 3 to infinity a to n by nb log n plus equal to c, for which the value of a, b, c belongs to are real, though the series not convergent. Not convergent means divergent. Not convergent means divergent. The limit exists, then convergent. Every quasi-sequence is bounded and every quasi-sequence is a convergent subsequence. And this sequence is what? So a is modulus less than, first to check that a is modulus less than 1, b belongs to c belongs to r. हो सकता है क्या? If a is modulus less than 1, suppose a is equal to 0. Suppose a is equal to 0 and b c belongs to 1. Suppose b is n 1 and c is 1, and that this summation value is 0 is 0. This value is 0 means a value 0. 0 means this is convergent. This is a convergent. What we have to give, but हमको क्या प्रमाणित करना है, जो सीरीज है वो डाइवर्जेंट होगा. सो ऑप्शन 1 इज डिस्कार्ड. Not going to that option 3. Suppose option 3. So b is less than equal to 1. B is less than 1. B is less than 1. That means suppose n2 over b is less than n2 over 1. So 1 by n2 over b, which is greater than 1 by n. So 1 by n2 over b log n with base e to c, which is greater than equal to 1 by n log n with base e plus c. We know that 1 by n by log n c is a what? This series is divergent. How to say this series is divergent? Now we have obviously know that 1 by n log n. This series is what? This series is divergent by log series, by ratio test. Ratio test. Limit 1 by n enters to infinity 0. But limit 1 by n tends to infinity equal 0. Suppose AK BK series. AK BK series means suppose AK is convergent and BK is not convergent. We have actually know that one theorem that AK is convergent but BK is not convergent. Then series is divergent. Then series is divergent. Then series is what? Then series is divergent. The series is divergent. So this series is divergent. this series is divergent, that means which is this series is divergent means this divergent. Obviously. So option 3 is over true. So option 3 is true. Now to check that option 2. Option 2 is how? Now to check that option 2. Suppose A is equal to 1, suppose B is equal to 1. B is equal to 1. And suppose C is anything, suppose C is equal to 1. That is real. Then summation A is equal to 1 to power n 1, n to power b. Suppose n is equal to 1 to power b is equal to 1, log, suppose log n, suppose log n, suppose. And n to power 1 is suppose n is equal to n to power 1, n log n, 1 by n log n. This series is what? And how to series this series is what? 1 by n log n series. This is convergent series. This is not convergent. This is convergent series or divergent series. This is what? Limit ak bk. Suppose by ratio test, limit 1 by n tends to infinity 0. But limit n tends to infinity. But limit 1 by log n. N tends to infinity, log infinity, 1 by infinity 0. But this is not same term. Suppose this series to check out that n by n plus 1. So obviously n plus 1. N is equal to 1 by n log n. Then n plus 1 how much? 1 by n plus 1 log n plus 1. Now check this ratio test. This series is very important, very. Now this series is very important. Suppose n plus 1 by n. So limit n tends to infinity. Limit n tends to infinity. N plus 1, that is 1 by n plus 1 log n plus 1 into by n 1 by n log n. So n into log n. Suppose n by n by n. N and cancel out. This is infinity. Infinity by this is also infinity. By L hospital rule. L hospital rule. How this limit n tends to infinity. 1 by n log n. N plus 1. This is log n. This is 1 derivative. Then 1 by n plus 1. Suppose n, that is log n plus 1, that is 1 plus 1 by n plus 1, that is 1, suppose. It is 1 by n plus 1, that is 1 plus 1, that is plus 1, log n plus 1 into this value is 0. Obviously, this value is 0, and this value is 0. So the series is convergent. So series is convergent, but this we have to show that divergent. This is false. A is minus not possible. Minus 7. This series is what? Minus 1 over 1, and B is greater than 1. 1. C is log n. This series is not. This series is also convergent, not divergent. So only option 3 is correct. But we have here एक बार एक नए वीडियो लेकर आऊँगा ज़रूर।